quantum numbers. Now, Schrodinger wave equation, when it was solved, it led to the quantum numbers. When we solve the Schrodinger's wave equation, we get the quantum numbers. Now, quantum numbers are like the address of an electron. For example, if I want to locate a student named Rajesh who studies in class 12th E of DPS. So what I'll do is, I'll first go to the DPS school, then I'll go to class 12th, and in class 12th I'll go to section E. So this entire thing gives me the school address, or rather the address of Rajesh in a particular school. So same ways we have the address of an electron. That is the exact location as to where the electron is located. So there are 4 quantum numbers. First is the principal quantum number. Which we designate by small n, and n can have whole number values, positive whole number values, it cannot have 0 as its value. Okay, then it gives the energy of the electron. I'll tell you how it gives the energy of the electron, and also the distance of electron from the nucleus. Now let's come to this. For example, now this is your nucleus, and if n is equal to 1, then the electron is present here in the first shell, that is first energy level. So your electron, you can say, is nearer to the nucleus. Supposing n is equal to 2, the electron will be present in the second shell, or the second energy level. Now as it moves away from the nucleus, the energy of the electron goes on increasing, and the distance of the electron also increases. So as it moves away from the nucleus, the energy increases, okay, and the distance of the electron from the nucleus also increases. So n, which is the principal quantum number, it gives you the energy as well as location and distance of the electron from the nucleus. Then second, you have the subsidiary quantum number designated by small l. It is also called azimuthal quantum number, also called angular momentum quantum number, and this arises from the fact that the electron is revolving in a circular or an elliptical orbit. Now if an electron is moving, it will have mass. It has mass as it is. It will have velocity because it is moving, and because it is moving in an elliptical or circular orbit, it will definitely have a radius. And MVR is nothing but angular momentum. So due to the angular momentum which arises due to the movement of the electron, you have the angular momentum quantum number. Now, as I said, it is designated by small l, and this small l has values up to n minus 1. For example, if n is equal to 3, L can have 0, 1, 2. That means up to n minus 1. Here n minus 1 is 3 minus 1. This is equal to 2. So it can have values up to 2. Another thing is total values of L is equal to n. Total values of L will be equal to n. Let's take an example. N is equal to 3. L will be equal to 0, 1 and 2. How many total values does it have now? 0, 1 and 2. That is total 3 values. And what is the value of n? 3. So if n is 3, then total values will be 3. Now let's investigate further. Let this be n and let this be L. If n is 1, L will be 0. And if L is 0, we will have the S subshell. And n is 1, so total value of L will be 1 only, that is 0. If n is 2, L will be 0 and 1. If it is 0, the subshell will be S, and if it is 1, the subshell will be P. If n is 3, total values of L will also be 3, 0, 1 and 2. This will be S, this will be P, and this will be D. So I'm sure now you must have got an idea as to what L is, what subshell is, and what N is. Let's move on further. The third quantum number is the magnetic moment quantum number. And magnetic moment quantum number, and it is designated by small m. Now it arises from the fact that the electron is revolving around the nucleus. Electron is negatively charged and the nucleus is positively charged. Due to the negative and the positive charge, there arises a magnetic moment between the two. And this magnetic moment interacts with the magnetic moment of the earth, because earth is also a magnet. Okay? And due to this, you have the magnetic moment quantum number. Now magnetic moment quantum number m, this is equal to minus L to 0 to plus L. And total values of m is equal to twice L plus 1. Let's see how. If n is equal to 3, L will be equal to 0, 1 and 2. And m will be equal to, for 0, m will be 0 only. So it has twice L plus 1, that is 2 into 0 plus 1, that is equal to 1 value only. So you have only one value, that is 0. And because there is only one value, so this is the s orbital, so it's s subshell, sorry. So s subshell will have only one orbital. Then L is equal to 1, that means m will have minus 1, 0 and plus 1. This is P subshell. That means P subshell will be, it will have 3 orbitals, minus 1, 0 and plus 1. Another thing to be noted here is, as I said, total values of m will be equal to twice L plus 1. So if L is equal to 1, then m, total values of m will be 2 into 1 plus 1, that is 3. So total values of m are 3, as you can see, if L is equal to 1. So if L is equal to 1, m will have minus 1, 0 and plus 1, That is, and another thing is, if L is equal to 1, you will have p subshell, and this p subshell will have 3 orbitals, -1, 0 and +1. Fine. Let's take if L is equal to 2. In that case, M will be equal to -2, -1, 0, +1 and +2. Now if L is equal to 2, it is the d orbital, d subshell, sorry. And as you can see, d subshell will have total -2, -1, 0, +1, +2. That is 5 values or 5 orbitals. And we will make it like this. -2, -1, 0, +1, +2. Next, if n is equal to 4, L will be equal to 0, 1, 2 and 3. We've already checked out for 0, 1 and 2. Let's see if L is equal to 3. If L is equal to 3, M will be -3, -2, -1, 0, +1 and +2. That means M will be equal to, how many values will be there? Twice L plus 1, that is 2 into 3 plus 1, that is 7 values. And as you can see here, there are total 7 values. Let us now make the M, and this for L is equal to 3, the subshell will be F, and we will make it like this. -3, -2, -1, 0, +1, +2, +3. Now we come to the next quantum number, and that is the spin quantum number. Designated by small s. Okay. Now, an electron can revolve around the nucleus in 2 ways. One is in the clockwise direction, and the spin quantum number will be +12 in this case. And it can also revolve around the nucleus in the anti-clockwise direction. Sorry. And the spin in this case will be -12. So for each value of M, that is, let's say if this is the d orbital, this is the d subshell. This d subshell has 5 orbitals. In each of the 5 orbitals, 2 electrons can be accommodated with opposite spins. One in the clockwise direction and the other in the anti-clockwise direction. For every value of n, two electrons can be present. That is, if we have the s subshell, which has only one orbital, the maximum capacity is 2. 2 electrons with opposite spin. If it is a p subshell with 3 orbitals, the maximum capacity is 3 multiplied by 2, 6 electrons with opposite spins. If it is a d subshell with 4 orbitals, the maximum capacity is, with 5 orbitals, the maximum capacity is 10 electrons. And for the F subshell, with 7 orbitals, the maximum capacity is 14 electrons. Now, let's take out the quantum numbers for 2p4. Now, this gives you the value of n. P gives you the value of L. So, for 2p4, let's first make this subshell. This is 2p. Pairing of electrons will occur once you have filled 1 electron each of the orbital. So this is 2p4. Okay. So this is 2p4. Now here this is -1, 0 and +1. So n is equal to 2. If L is 0, it is S. If L is 1, it is P. So L is equal to 1. As far as M is concerned, you can see the electron is located in this orbital. So M is equal to -1. And you have the 4th electron. For the first electron, the spin is, for this it is +½ for this it is -½ So S will be equal to -½